Hello everyone, I'm Mahathi with Global cli-MATES. Welcome to our next episode in the Introductory Earth Sciences. Today we'll be taking a deeper dive into the geosphere, which we briefly touched upon last video. And specifically we'll be taking a look at Earth's inner structures. And so let's get right into it. So here I am drawing a circle to represent Earth, because Earth is a sphere. And so we're looking at a cross-section of the planet. And so, as you may know, Earth has several layers inside of it, but those layers can actually be determined based on two primary categorizations. So the first thing we're going to take a look at is composition. So essentially what this means is the layers underneath Earth's surface, can actually be determined based on the composition of those layers. So when we talk about composition in this sense, we talk about, the various elements that make up those specific parts of the structure. And, a more simpler way to look at it is also just thinking about the density of these layers as part of the composition. It's a easier factor to look at so that we can actually distinguish the three primary layers that are determined using the compositional method. So the first layer we have is known as the crust, and it's this very thin layer of Earth. It's what we see here on the surface, and it extends a little bit past it. Obviously, not to scale, because I can't draw it within scale. The crust is actually very, very thin compared to the entire depth of the Earth. And so this first layer is known as the crust. And then the second layer that we can use, we can determine based on the composition method. The composition classification is known as the mantle. And so the crust, it would be this, this thin layer out here. Then we have the mantle, which is this thick section over here. And then the third compositional based layer is known as the core, which is right here. And so I mentioned that, these layers can actually be distinguished by their density. And so in this case, if we think back to the formation of Earth, right? At some point in its history, Earth was this very molten ball of these various metals that were all melted, right? And so as the Earth started to cool, the denser, heavier metals started sinking towards the center of the Earth, where the gravity is like the strongest, and the lighter elements and the lighter metals stayed at the surface. So when we actually take a look at the density, we can see that the crust is least dense and the core is most dense, which again happened due to the stratification that occurred when all this stuff was molten. So all of it. Yep. And then the second way we can take a look at Earth's internal structures is using physical properties, right? So composition is just, like the density. What is it made out of? Physical properties start taking a look into the strength of the materials. And so, for example, is this part of the planet solid, or is it liquid? Is it stiff? Is it weak? And this is just another method that we can use to classify Earth's layers. So when we take a look at differentiating Earth's layers using physical properties, we can see that we still have the crust, right? So the crust is still this, this thin layer right at the surface of the Earth. And as you have probably experienced, with rocks, right? The rocks that we see are, very hard and very brittle. And so that's kind of one of the markers of the crust. But we can also see that as we start going into the mantle, there are still really hard, tough rocks. And so this upper part of the mantle also exhibits, these hard, brittle tendencies. And so what we can do here is, let's say we take a section, a little bit of a section, including the crust, the upper mantle. We can kind of extend this out, right? So we have like a bigger panel. So here at the top, in the green, we have the crust. And then we have a part of the upper mantle here. So upper. And then the lower mantle starts below this line. And so since both the crust and upper mantle exhibit similar physical properties and they're hard and brittle, together they form what's known as the lithosphere. And then I mentioned that, like, you know, as we go past the upper layer into the lower layers, the temperature starts increasing. And as the temperature increases, this hard rock starts to become more mobile. And so it's not a liquid, definitely not a liquid. It's more of a solid than a liquid. But if you think of very, very slow plastic deformation, if you think about like magma or like slowly melting plastic, you can imagine how slowly it moves around. That's kind of an analogy to what this asthenosphere looks like. And we can see that the asthenosphere is still a part of the upper mantle, but it's below the lithosphere. And so after we have the lithosphere, we have what's known as the asthenosphere. And again, it's weaker and mobile. And so if we go back to kind of like this little zoom in close up, the lithosphere is kind of this first 100 kilometers. So that's the lithosphere. And then the asthenosphere kind of extends out for 300 kilometers below it. So together they span maybe the first 400 kilometers of Earth's structures, internal structures. And then, of course, below the asthenosphere, we go into the lower mantle. So that's actually it. We have, after the asthenosphere, the lower mantle, and sometimes it's also known as the mesosphere. And there's kind of, what's important to note here is that these aren't, you know, firm delineated boundaries, right? We don't have hard lithosphere and suddenly, you know, mobile asthenosphere. There's a gradual change as we go from the lithosphere to the asthenosphere. And as we go from the asthenosphere to the lower mantle, we have to remember that there's two kind of forces at play, right? So there's the temperature. As the temperature increases, the rock becomes more melty and soft. But there's also pressure. As you go deeper into the earth, the weight of the rock above it can apply, you know, a very crushing pressure. And this pressure kind of counteracts the temperature. So increasing temperature makes the rock more liquidy, but increasing pressure makes it more solid. And as we go from the asthenosphere towards the lower mantle, we see that pressure starts to, win again, and the rocks start getting harder. And so even though these rocks in the lower mantle are still, like, exhibit, you know, more strength, again, there's still the possibility of flow happening due to the heat and the very slow movement of rock in the mantle. And then now we're down to the core. But when we're looking at physical properties, the core is actually separated into the outer core and the inner core. So the outer core and inner core have the same composition as we saw in the compositional classification. They're both, iron and nickel. But the difference between the outer core and the inner core in the classification based on physical properties is that the outer core is liquid, whereas the inner core is solid. So with regard to physical properties, they're obviously different. And so we can even draw that in here. So now we have the solid iron nickel inner core. And so these are the two primary classifications for Earth's inner structures. And to kind of give you, as one last thing, to give you some reference to actually how deep the Earth is. The entire Earth, so if we draw a line from here to here, right? So I guess the radius of the Earth is approximately 6,400 kilometers, more specifically 6,371 kilometers. So that's the entire radius of the Earth. Now the crust, and we'll get into this in the next video, but the crust is, it actually varies from place to place depending on whether we're under a continent or under an ocean. But the crust is, you know, typically somewhere between 7 and 35 kilometers. And so here we have, you know, approximately, you know, 30 to 100 kilometers. Depending on, you know, where we are. Because if we think about, you know, on continents, we have mountains, for example, and mountains can have crust, you know, can be situated upon crust that's over 70 kilometers thick. And so the crust is approximately, like, you know, maybe it's less than 100 kilometers. And then we have the mantle. And as you can see from this diagram, the mantle definitely takes up the most amount of space on Earth. It's actually roughly 82% of the volume of the Earth, and the mantle is 2,900 approximately kilometers deep. So from the surface down to the edge of the mantle, we have 2,900 kilometers. And then, of course, taking a look back into the core, from the outer core, edge of the outer core to the inner core, it's like roughly 200, it's roughly like 2,000, another 2,000 kilometers. And so we go from here to the inner core. This is 5,150 kilometers. So you can see, you know, it's roughly 2,250 kilometers. And then we have the inner core. The inner core goes from this 5,150 to the 6,371. And yeah, so that's kind of just like a little bit, because I can't draw the diagrams to scale, it's just a little bit of more information to help you visualize what the Earth's inner structures look like. So I hope today was helpful. We went over the physical and compositional ways to classify Earth's inner layers. And if you did find it helpful and informative, please like and subscribe and comment down below if you have any suggestions for future content or any questions. And I hope to see you in the next video. Bye, everyone!